Hello everyone, in this post we are going to talk about horizontal projectile. Just the scenario is like this. Let us consider a vertical wall having a height h from the ground. We are now throwing a body of mass m horizontally with a velocity u. Very clear that it's having only initial velocity along x-axis. I want to know what is the path of this. So I can say I need not resolve this into components because it's already only along one axis. We need to resolve someone into components only when it is in between the two axes, but it's purely along an axis. So I need not resolve this into components. I can calculate, say, u along the x-axis is u as given. There is no u along y-axis. Why there is no u along y-axis? Because we have not given any velocity along the y-axis initially, rather we have thrown it horizontally. I want to know, use the same equation like we have used earlier, s equal to ut plus half at square. Calculate the displacement along x-axis as well as y-axis. Say for example, along y-axis the displacement that it covers is y. I am just using the above equation. U is 0, half a is plus g because now it is coming down. So the displacement y equal to h is nothing but equal to half gt square. Similarly, I want to calculate how much it displaces along x-axis with time. Along x-axis, I would like to use the same formula. Ut plus half at square. Let s is x, velocity is u, but it's very clear that there is no acceleration along x-axis because the only acceleration acting is acceleration due to gravity. It's not there along x-axis, it purely acts along y-axis. So x is nothing but ut. I can write, if it is required, t is nothing but x by u. By putting this in this equation, from equation number 1, I can write y equal to, or else h equal to half g t square. T is nothing but x by u. So it's nothing but half g by u square and x square. I know g by 2 u square is constant, some k, x square. So we have got a format y equal to x square, which is a representation of parabola, semi-parabola, like this. So I can say this is also going to take a path of parabola. So I would like to say this horizontal projectile from a certain height takes a path of parabola. Takes a path of parabola. This is the point that I would like to prove at this junction, right? Horizontal projectile is also going to have a parabolic path when it is thrown horizontally from a certain height, right? Thank you.